Alright guys, here we have a 25 volt battery connected in series with R1 resistor 5 ohms, and here we have two resistors in series. So I'm going to go ahead and find the equivalent resistance, which is going to be equal to R1 plus R2 in parallel with R3, which is going to be equal to 5 plus 8 in parallel with 2, which is going to be equal to 8 times 2, 8 plus 2 there, 5 plus 16 divided by 10, you get 5 plus 1.6, 6.6 ohms is the equivalent resistance. So now I can go ahead and solve for I. Is equal to V by R is equal to 25 volt divided by 6.6 ohms. I is equal to approximately 3.78 amps, and the new circuit would be drawn as 25 volt, 6.6 ohms. There you have it guys for this example. Alright guys, for this example we're going to use a 20 volt battery that's going to have a 2 ohm resistor and a 2 ohm resistor in series, a 3 ohm and a 5 ohm in series. So let's go ahead and find the equivalent resistance here and here, and then we'll just say our equivalent 1 is this, which is going to be 2 plus 2, which is 4. Our equivalent 2 is going to be 3 plus 5 is 8. We can redraw the circuit as 20 volt with the 4 ohm resistor along with the 8 ohm. And these guys are in parallel. Don't get that confused with series. This is actually a parallel connection, so we're going to go, our equivalent is going to equal 4 parallel 8. 4 times 8 divided by 4 plus 8 is 32 divided by 12, which is approximately 2.66 ohms. Now we can solve for I is going to be equal to 20 divided by 2.667. 20 divided by 2.667, 7.49 amps. So the current running through this circuit is actually only 7.49 amps.